All right.
And did your camera stop?
Yeah, it's back up now.
Okay.
Yeah. Okay. The best that I can think of. All right. I tore the meniscus in my knee. Okay. And had to have the surgery. And in the surgery, you know, that takes place, I still have issues with my knee. And the reason for that is, do you remember the articular cartilage that's on the end of the bones? Okay. Well, because I now have less cartilage in there, they can have some rubbing action. Okay. And that would be considered a constant irritant and therefore keeping the inflammation in the knee. Yeah.
So it is the same sort of inflammation, it just didn't have a barrier breakage.
Right.
Okay.
And if you think about arthritis is where there is something that's going on with the tissues that are in that joint that's like a constant irritation.
So
Yeah.
what stimulates the bursitis?
Now, bursitis is what's going to be happening to the fluid-filled sacs, okay? So if you look at the joints of the body, all right, each of these joints have bursa that are in them, and they're simply little sacs filled with fluid. And if you think back to our structure of a joint, those sacs of fluid are to help something that has a muscle over it, okay, tissue, tendon or something over it, to help keep it moving freely. Now, when you get bursitis, it's an inflammation of that fluid-filled sac. And it could be, you know, that they might have to use steroids or something like that to help that inflammation go down. The goal is hopefully some of these anti-inflammatories that have been created are decreasing the inflammation in that area of the body, okay? But my question is, and I haven't quite found the answer to it yet with anti-inflammatories, my question is it stopping just signals for the pain that are going to the brain, or is it actually reducing that inflammation in that area? That's a huge question I have about anti-inflammatories. Does that make sense? Okay, so the chemical barriers, these right here, we've now passed that first line of defense, and we have moved into the second line of defense because we have breached either the skin or the mucous membranes. And so the body, this tissue that is now exposed, okay, this tissue is going to be giving the response of the inflammation, okay? That is coming from the tissue that's now exposed. And so when we're going to see inflammation, the actions that come with inflammation, well, because we have now breached that skin, for example, let's think about a cut, okay? Haven't we damaged blood vessels? Okay, and do you remember how in the response from the blood vessels, they dilate so that they can get materials to the area that's been breached? Okay, so blood vessels dilate, the capillaries become more permeable, and therefore fluid begins to leak into the tissues. And the hope is that it's bringing these cells that can come in and pick up the dead cell, clean up the cell debris. If there's any bacteria or something that's trying to enter, that it's going to eat that up too, okay? So the tissues, red, swollen, warm, painful, okay? Depending on what the cut might be, all right? Because we have increased the permeability of the vessels, this means white blood cells now get to come to the region. They're now going to invade. Now, what the goal is, hopefully the white blood cells coming in are going to be able to eat up all the dead stuff and anything's trying to invade. When that happens and you have a cut, have you ever had a cut that as you know it began to heal and stuff, that it formed pus? Gotta love pus, right? I mean, you know, they were really inventive that day in lab, okay? And, you know, that formation of the pus, if we begin to have the white blood cells, the cells that it's trying to kill off, and debris accumulate without it getting cleaned up properly, we're gonna have the pus. Yeah, love that term. Sometimes though, that can, you know, lead to infection. You gotta have antibiotics, anyway. Okay, so as we begin to have that blood come into that area that got breached, do you guys remember this? Do you remember the fibrin clot? Because we have the cells in the blood that can give rise to a fiber and create the fiber clot. Remember that? Fibroblast, meaning we get to give rise to the fibers. Hopefully, phagocytes have arrived in those white blood cells, and they're going to begin to eat stuff up. And then we get the chemicals that can travel in the blood to stimulate mitosis so that we can begin to have the cells of the vessels, for example, the blood vessels, begin to duplicate and repair. And this is all taking place. This takes place in seconds. If you think about a breach, let's think about a small, well, I mean, still the process is going to start occurring, okay? But think about a cut in your skin, okay? That process, how long do you usually bleed? Let's say you did a paper cut, a good one, where you know you're actually like, ugh.
Less than a minute.
Huh?
Less than a minute.
Less than a minute. Okay? I can't record this. Process that we have as this now second line of defense. In the phagocytosis, believe it or not, phagocytosis becomes important for the body with the immune system, because with phagocytosis, as those blood vessels get broken, and those blood vessels where now we have rushed the blood, in the blood are different components, it's coming in to help with that particular breach to the outer world, okay? We want to make sure that these materials that have been produced and have been moving around in the blood, that they're going to get to that area and they're going to be able to fight, okay? And under this second line of defense, this process of phagocytosis, believe it or not, is very important because it can come in, it can remove foreign particles. We're going to see that we can have this process of phagocytosis taking place in areas that help give rise or filter or do something with the blood. The majority of our phagocytic cells are neutrophils and monocytes. So these are they're a little more numerous under white blood cell counts, okay? We do have a norm, a range that they should be in, but these are the ones, if you think about it being our second line of defense, this means that they're going to be mounting attacks very quickly, all right? These macrophages, these big cell-eating cells, because that's what they do. They eat other cells, okay? We're going to find them, especially in the blood. In some cases, they'll migrate into the tissues, wander around. They can have this ability to duplicate when needed. There are chemicals that at the time we have a breach, okay, chemicals can attract them. So in the blood, there are chemicals that can attract these cells to an area. This attraction is termed chemotaxis. The chemicals attracting those cells. If a monocyte leaves the bloodstream, goes into the tissues, and remember, do you guys remember how long their life might be? Do you guys remember any of that?
Can they sit in the cells for years?
No, these are the ones that are only around for a few days. Okay? So, if they leave the bloodstream, move into some tissues, and wander around to eat stuff up, okay, they're going to now be termed that macrophage. So, these monocytes, these neutrophils, that monocyte that will leave the blood, move into tissues, that'll be termed the macrophage. Now, one monocyte that becomes a macrophage, one, can engulf up to 100 bacteria. Do you happen to know how quickly bacteria may duplicate once you've exposed the outside body, the outside world to the inside of the body? On the norm, each bacteria duplicates every 20 minutes. So if we had that paper cut, and what's the size of a bacteria compared to an animal cell? We're talking a speck to something that's already microscopic. So if we were to cut that area, let's say we're exposed to 1,000 bacteria in that one cut. In 20 minutes, 2,000, 40, 80, and one of these macrophages can scoop up about 100 of them. So at a time of a breach, what do you think's happening at that time of a breach? We're rushing them to that area because we want to make sure that it's taken care of before those bacteria get to enter the body and have a really nice environment. So in the body, we have something called a mononuclear phagocytic system. Reticuloendothelium. What does it make you think about?
Reticular fibers.
Reticular and endothelium, a single layer of cells. All right? So we find that this system is going to be made up of monocytes, neutrophils, and macrophages. Of this system, of these white cells, neutrophils are going to be the first ones to arrive at a breach. So when something gets breached from that skin or that mucous membrane, neutrophils are the first to arrive, and they die immediately after they ingest the pathogens. that they can ingest. So their lifespan is not very long. They'll fly around in the bloodstream until they get the signal to go somewhere. But once they enter the bloodstream, they still don't have a long lifespan. And if they have to be called into action somewhere, as soon as they ingest something, they'll die. Take a break, back at 12:30.